Video will be on section 6.3 on solutions of polynomial equations. The following statements regarding the function f are equivalent. We've done this before. If we have a polynomial function f of x minus a is a factor of f of x. That happens when a is a zero of the function, when a is a solution to the equation f of x equals 0. A is the x-intercept in the graph, you can see. A0 is the x-intercept, and the graph crosses the x-axis at the point A0. So really this would be better said, A0 is the x-intercept. Here we have a polynomial function in factored form, and we need to find the zeros. Well, basically we are saying that this polynomial function equals 0. That means x plus 3 equals 0. So x equals negative 3. X minus 4 equals 0. So x equals 4. And 2x plus 5 equals 0. So x would equal negative 5 halves. Those are the zeros. The solutions then are negative 3, 4, and negative 5 halves. That'd be the solutions to p of x equals 0. And the x-intercepts will be negative 3, 0, 4, 0, and negative 5 halves, 0. We have a situation, we have a box can be formed by cutting a square out of each corner of a piece of tin and folding the sides up. So what happens is we have this piece of tin, it does need to be a rectangular shape, and we're going to cut a square out of each corner, meaning you understand these are squares, and then we fold along these lines, and that these become the sides of the box. This is the bottom. So we have this piece of tin is 18 inches by 18 inches, and each side of the square cut out has a length x. So each of these are an x. Well, we use the formula volume equals length times width times height to find an equation that represents the volume of this box. So the volume and equal. Well, the length will be here, and that will be 18 inches minus an x and an x, so minus 2x. So 18 minus 2x. And this side of the bottom, the width, wait a minute, that's going to be 18 minus 2x again. So this can be squared and find an equation that represents the volume of the box. Well, the height then will be x. So this is my equation that represents the volume of the box. Now we're going to use that equation we constructed to find when the volume equals 0. So we had the equation 18 minus 2x, the quantity squared, times x equals 0. Oh, well then 18 minus 2x equals 0 twice, or x equals 0. So this will give me 2x equals 18, so x equals 9, and x equals 0. So those are the values of the x that will make the volume of the box 0, which makes sense. Here we have our 18-inch square, and if we cut 0 out of it, we don't have anything fold up. Of course, it has volume of 0. And if we cut 9 out of, there I have the square, and then cut this square is 9 on each side, and this square is 9 on a side, and this square is 9 on a side. we have nothing left to make a box with. Graph that function as gives the volume of the function of the square cut out using x intervals that make sense for the problem. Well, we have no box at x equals 0 and x equals 9, so the interval that would make sense is between those two. Going to my calculator, here we've entered the equation, and let's look at our window. We decided we needed 0 to 9 for our x values. For our y values, well, we have 0 at those places. And just to make sure we covered everything, let's have this one go to 500. And look at the graph. So it goes up and then it comes back down, started at 0, went up fairly fast, and then it comes back down gradually. But this is our graph. Another way to solve polynomial functions is to find the real roots for equation x to the nth equals c, take the nth root of both sides. So x equals the nth root of c if n is odd, because then my answer will depend on if c is positive or negative, then we'll have a then we can have a negative root if c is negative. But x equals plus or minus the square root of c to the nth if n is even and c is greater than or equal to 0, since we can't find a square root or a fourth root of an odd number. Let's solve some of these equations. So we have x to the third equals 64. Well, what we're going to do is just take the third root of both sides. So the third root and the third root. The third root and cubing it cancels each other out. So x will equal, and the third root of 64 is 4. So we've solved that equation. This one, we want the x to the fourth by itself before we find the roots. So let's divide by 5. X to the fourth equals 81. And now I can take a fourth root. And x can equal, now because this is a fourth root and it's even root, plus or minus, and then the fourth root of 81 is 3. So plus or minus 3. Here we have a square root. Let's start by dividing by 4. So x squared will equal 50 fourths. And let's take the square root of both sides. So x will equal plus or minus the square root of 50 fourths. Now we can break that into the square root of 50 over the square root of 4. So x will equal plus or minus, now 50 is 25 times 2, so will equal 5 times the square root of 2 over square root of 2. The square root of 4 is 2. So this would be the solution.